Hello, welcome back to Alien Space Talk. My name's Andy. I'm so pleased you're enjoying these podcasts and you keep wanting to learn more. As I said before, this week's episode is going to be about the amazing moons of Saturn and their diversity. As we know, at the minute, there's about 140 moons on there, and they're all different, all unique, and Saturn's family of moons is diverse as it is intriguing. We're going to go through some of the highlights and some most interesting Saturn's moons, including the largest moon Titan and its endemic ice moon Enceladus. I apologise if I sounded wrong. So let's start this cosmic journey. Saturn is the second largest planet of the solar system. It's renowned for its stunning ring system, but its collection of moons is just remarkable. Saturn's moons range from tiny moonlets to the giant Titan, each offering a unique insight to its process shaping our solar system. We don't study the moons. We don't know more about that. So if the moons can be made, if we understand how the moon's made, we understand how the Earth is made, and so on. And also, it helps us learn and evolve our knowledge of the solar system. One of the most exciting aspects of Saturn's moons is their potential to help us understand more about the conditions that might support life. That's life as we know it. Moons like Titan and Enceladus have features that intrigue scientists that could potentially harbour the ingredients for life. Now remember, life is made of biological material. It takes millions of years, as we know from our own development. And these moons have the equipment to make life, but has it made life? We don't know. That's the honest truth. So let's see if we will. Maybe you can help us with that. So to understand the moons, we need to understand all this. We need to understand a little bit more about the moons. So the first moon is Titan, a giant moon with a thick atmosphere. It's the second largest moon in the solar system. Titan is a remarkably thick, nitrogen-rich atmosphere. Remember, we're a nitrogen-oxygen atmosphere. This is just nitrogen. It's even denser than Earth, so it's a lot thicker. Dense atmosphere creates a hazy orange appearance, and the surface is obscured by thick clouds. So if you ever look at the moon, you can actually get a really powerful telescope and a really good look at it. You'll see it's a hazy orange moon rather than the grey moon we have. Titan is unique because it has lakes and rivers of liquid methane and ethane. These are hydrocarbons. These hydrocarbons are in a liquid state due to Titan's extreme cold temperatures, which are around 290 degrees Fahrenheit or minus 179 degrees C. I was asked to add in the different temperatures. Hope that helps. These present liquids on Titan's surface, along with the complex organic chemistry, makes it a prime candidate for studying prebiotic conditions. In fact, Titan's atmosphere and surface have similarities to early Earth, which is why it's such an intriguing target to research. Now, we don't know much about the Earth's atmosphere back millions of years, billions of years ago. We know dinosaurs, what they ate the plants, they ate each other, but we don't know much about the atmosphere. And we're learning that slowly through the minerals and everything we discover by doing archaeological digs. However, if the atmosphere is more nitrogen, could we look very different because also our lungs produce sucking the oxygen and breathe out carbon dioxide? What would our lungs look like, or what would we look like if we're breathing in nitrogen and breathing out a different chemical, nitrogen oxide? We don't know. It's saying that this could be happening on Titan. Think about it. Aliens may be very similar or very different to us, but we all have the same building blocks to start with. NASA's Cassini mission, which orbited Saturn from 2004 to 2007, provided a wealth of data on Titan, including images of its surface, which is why we know there's rivers and lakes, and measurements of its atmosphere. Now, remember, that's the atmosphere today between 2004 and 2017. Doesn't mean it was very different millions of years ago. Just like we are putting too much pollution in our atmosphere, is something changing Titan's atmosphere from other things? We don't know. However, future missions, like the upcoming Dragonfly mission, aim to explore Titan's surface, its potential chemical process that could be similar to early Earth. So Dragonfly is going to go there and actually see what the surface is like, how much it is similar to Earth, and then using that data, we're going to collaborate and analyze and understand and see, hang on, this is very similar to Earth. If it keeps going or if it warms up, maybe it'll become more like Earth, or hang on, there's life here, let's leave it alone. We don't need to do anything to let the life evolve on itself. We need to look at it and understand it and see what happens. We can't just go there and see what happens. We need to learn a little bit about it. So Dragonfly mission is going to tell us a hell of a lot more than we already know, and we still have a lot to learn. So don't forget, we're still at the baby steps of learning about space, and this is one of the baby steps we need to take. The next moon is Enceladus. I apologize, I said that wrong. An icy moon with hidden oceans. A small but highly intriguing moon. Enceladus, best known for its geysers that shoot water vapor and organic matter molecules into space from beneath its icy surface. So it's shooting these giant geysers from the very bottom of its oceans all the way into space. And it contains organic molecules. That's really, really interesting. These plumes were first detected after Cassini spacecraft, which revealed that the moon had a subsurface ocean beneath its icy shell. Now, this is really important. We know that's an icy shell. We know there's an ocean underneath, and we know these giant geysers are forcing water out with organic material inside into space. That's that powerful. But if it's shooting these geysers in space, where's the water getting recycled from? How's it collecting more water to replace what it loses? It's an interesting question. We're not quite sure what's going on there. The ocean of Enceladus is kept liquid by tidal heating. Now, we covered that before from the moons of Jupiter. Caused by Saturn's gravitational forces, heating creates an environment where hydrothermal activity could occur on the ocean floor, potentially creating conditions that might support life. If you think about it, if we're on the surface and we shake the earth, everything rattles, yes? But if you do that in water, it doesn't rattle as much. The water helps hold things in place. So it's very interesting to see how these different things change and everything like that. The discovery of organic molecules in the plumes, along with detection of hydrogen, which could react to carbon dioxide to produce methane, adds to the excitement about the potential of life on this icy moon. Now, even though that sounds really complex and everything like that, think about fish in the water. They've got to breathe out, they've got to do their business and everything in the water. And they have to breathe out as well. And we need to reoxygenate water to make sure the fish stay alive because they're breathing out, remember. So we have to keep the oxygen going back in. And if you're in a river or something like that, the rivers ripple over rocks and everything like that and extract the oxygen from the atmosphere and put it into the water. Now, this is where it gets interesting. Enceladus is an ice planet, so it doesn't have rivers and everything like that on the surface. It's all on the ground. However, when we drill through Antarctica and we dropped the camera down to see if there's any life through the thick ice, we went down miles of ice, 2 miles underneath the ice. We dropped the camera down to see if there's anything living there. There's no sunlight, thick ice, shouldn't technically be anything there. And we discovered life, and we discovered over 100 different species of animals or sea life, from small crustaceans, shellfish and things like that, to actual different types of fish and so on. And these are alive in the coldest, darkest regions of our oceans. So Enceladus has a very, very strong possibility of having life on there. But how and what type of life that is, we don't know. And that's really, really exciting, especially for me. I'm sure you can hear my excitement. And it's going to be interesting as we go there. We go and study and learn this and find out, is there life there? What does it look like? And what's even better is, can we communicate with it? That's a key thing. And one thing that we're still learning today is how to communicate with species on our own planet. If we can communicate with fish, won't that make things better? We know whales communicate through songs. If we could understand them better, things would be even better. So there's a lot still to learn and a lot still to do. So we need to do more. And maybe you can help us with that. Maybe you have ideas on how we can communicate with other species, especially with species underwater. More about echoless geysers also contribute to material in Saturn's E ring. Now, before I mentioned there's different rings, different distance apart. E ring creating a direct link between the moon and the planet rings. Future missions could further investigate these plumes, such as signs for life and or more complex organic material. As I said, we need to look at these things. So even though it's spewing it out into the E ring, maybe we don't need to go under the water to have a look. Maybe we just need to discover the E ring. And maybe that E ring is rejuvenating echoless to have more material so it can keep producing more plumes. There's a lot of things we don't know and not sure on, and we need to discover it. But we need to figure these things out. That's why you're listening to this today, to learn more and do better. It's great. Another moon that you may not know about is Leptus, a moon of distinct two-tone surfaces. This is going to be interesting. Leptus, another fascinating moon of Saturn, is known for its striking two-tone surface. One in the hemisphere of Leptus incredibly bright and icy, while the other dark and is covered in mysterious carbon-rich material, which we don't fully know what. We know it's carbon-rich, but what was that? This stark contrast between light and dark is believed to be the result of both external deposits from another moon and thermal segregation. So the heat is playing an effect to separate these two colours. While the dark side absorbs more heat, it becomes more and becomes darker over time. So what material do you know that when it absorbs heat, it gets darker and it's carbon rich? Well, the easiest one that I know of is wood. Wood is very, very rare. We know it's here on Earth. And it's very carbon rich when it's burnt. It gets darker and darker and darker, but it disappears. This moon, Leptus, is absorbing light and things are getting darker and darker and darker. Now, I'm not saying it's wood by all means, but it's a carbon-rich material that does get darker. And the light is separated. It's bright, it's icy, but what's keeping the ice and keeping the heat and the ice separate? Something we need to discover. Lepta also features massive equatorial ridge that encircles most of the moon. This ridge, which is rises up to 20 kilometers high in some places, gives Lepta a unique walnut shape. The formation of these ridges is still debated, but might be related to rapid rotation and or the collapse of a former ring system. So it may have rings, it may have a moon that broke up and then got pulled into it. We're not sure, but it could have span out and gone more oblique, like all the planets do. If there's planets that spin fast, they go faster in the middle. So maybe it span there and now it's slowed down and now it can't put itself back. But because it's got a light and dark half, something weird's going on here. I think we need to have a look at it. Two other moons, these are called mid-sized moons, Rhea and Dione. Unique features of their own. Rhea, Saturn's second largest moon, but classified as mid-size, has a surface marked with bright ice, dark material indicating a history of intense impact and internal processes. Dione, on the other hand, has a surface with large, bright ice plains and craters. Both moons show signs of tectonic activity, i.e. tectonic plates, they're moving, they're shifting, and their icy surfaces suggest they might have experienced significant geological changes. So unlike us tectonic plates shift the moon and volcanoes go off, they're frozen on the surface. These tectonic plates may still be moving, but there's nothing coming out of the volcanoes. So what's going on? That's really, really weird. It's really cool. Because if we can do that here and not let the volcanoes go off, would that be good for us or would that be bad for us? We don't know. But this is why these are really, really important. Both these moons have thin rings of their own, which was discovered by Cassio. These rings are faint and made of dust, fine dust, contributing to Saturn's complex ring system. So even though they're around Saturn and by Saturn's rings, they have their own rings. And even though Dione had rings that could have collapsed into it, there's still remnants of that ring still there. So it's always changing and we're always understanding more. But what's going to happen to the rest of these rings? Are they going to disappear? Are they going to create a new moon? What's going to happen to them? Because the particles do collide, remember. The moons of Saturn are diverse, as they are fascinating. They're very, very weird, but they're very cool. Some have life, some are just like a walnut. Each contributes unique insight into nature of the solar system. From thick, hazy atmosphere of Titan to geyser on Achelous and the distant features of Lepus, Saturn's moons provide a window into the complex dynamic process that shape planetary systems. They're changing, they're always changing, things are changing. And just because we've got the main planets, Pluto got declassified, and it's very, very different to all the other planets. The moons help us understand these different things, and they're really important. We do study them further. Hopefully you've enjoyed this. I do have the longer version of this available as well. Please like and subscribe, and I hope you enjoy. Thank you for joining me on today's exploration of Saturn's moons. Please don't forget to check out my website, spaceforalleducation.com, and I hope you enjoy us on our next adventure into Uranus. Take care.